Alright, so the topic today, direct variation. And that is a formula you need to understand. Up on the board. And hopefully you notice a similarity to something we have done recently even. That look like anything else we've talked about to you? I hope. Anybody? What does that look like? And there is one large difference, but what does that look like? Nobody? Where have we seen y and x paired together recently? Slope, intercept form. Okay, so this is much like a line in slope-intercept form. However, what's different about it? There's a k instead of m. So when you graph this, this actually will be a line, and k will be the slope of the line. However, in this more specific example, we call it the constant of variation, but k is still the slope. So we replace k with m, but really it still means the same thing. What's missing? What isn't there from slope-intercept form? Now we got y equals kx. What's missing is, Megan, b. So what does that mean about the intercept? If there is no intercept, and I know we have talked about this too, if there is no intercept, what is the intercept? No, not 1. What number would represent nothing? 0. So direct variation is a specific example of a line whose y-intercept is 0. And to think about an example of this, Taylor, how many ounces in a pound? You remember that one? 16 ounces is 1 pound. So if you're writing an equation for this, a formula perhaps maybe we should say to convert, we would say the number of ounces equals 16 times the number of pounds. That formula makes sense to everybody? I guess O is a bad letter to use there, but ounces equals 16 times the number of pounds, right? If I had 1 pound, 1 times 16 is 16. If I have 2 pounds, 2 times 16 is 32, so on and so forth. That makes sense to everybody? If I have 0 pounds, how many ounces do I have? 0, because the intercept of the line is 0, so it corresponds with that. In this case, what's the constant of variation? Nope. 16 is the constant of variation, right? What is the slope of that line? Nope. That's the intercept. 0 is the intercept. The slope is the same as, it's also 16, right? So 16 is both the constant of variation for this case of a direct variation and also the slope. So if it has a y-intercept other than 0, then it's not a direct variation. Also make sure you keep that in mind. So one thing they might do today is say, give you an example of an equation and ask you if it is a direct variation. So, yes or no? Is this a direct variation? And you should say, I'm not sure, actually. Why should you say, I'm not sure first, Millie? What do we have to do to this before we should determine it is a direct variation or not? Not x equals. We get y equals. So what do we have to do first to make it y equals something else? Add 12 to both sides. Good. So really we should have y equals x plus 12. So is that a direct variation? Why do you say yes? I'm going to say no. Yes, kind of, I guess. But what should direct variation never have? Plus or minus. So is this a direct variation? No. And let's ask this question. It's not a direct variation. It is a line. What's the slope of the line? I think I heard it. Nope. What's 12? Nope, because it's not a direct variation, so it definitely can't be the constant of variation. Plus or minus something is always the what are the two pieces of slope-intercept form? If 12 is the y-intercept. So what's the slope of the line? Nope. Slope should be a number always. Nope. What's the coefficient of the x term? 1 is the slope. 12 is the y-intercept. Sounds like we don't know this stuff well enough yet. Okay, let's try another one. Nope, nope, nope. Y over negative 3 equals x. We said that one wasn't. Okay. What do we have to do first? And multiply both sides by negative 3. We should get y equals negative 3x when we do that. Does everyone agree? Is this a direct variation? Yes. What is the constant of variation? Negative 3. What's the slope? Negative 3. Same thing, right? Constant variation, slope are the same thing. Now, what do we have to do first to determine if it's a direct variation? Move 2x. How do we do it? To the next question. Divide. I agree. So we get y equals 8 over 2x. What can we also do to that? 4. Okay. And I'll make it y equals 4 over x. Is it a direct variation? No. X has to be in the numerator. X is in the denominator. Is it a direct variation? No, it isn't. Alright, one more. Let's see. 3, let's do this. 3y equals x. Alright, what's our first step? Divide by 3. Y equals x over 3. Now be careful. What we said in the last example. X has to be the numerator, right? Is that the case here? Yes, so is it a direct variation? This is a direct variation. No y-intercept, and x is in the numerator. Now here's a difficult question. What is the constant of variation? Very good. 1 over 3, right? And it might be better to think of this as y equals 1/3 x. Everybody agree that those are equal? Okay, so the constant of variation in this case is 1/3. Millie, what's the slope? There you go. Okay. What else do we need to do? I think that's all we need to talk about today. Okay, so a few reminders. Millie, what do you know about the constant variation if it's a direct variation? Same thing as the slope. If it's a direct variation, what do you know about the y-intercept? It's 0, always, right? What else do we need to review here? If it has a y-intercept that's not 0, what does that mean? If a line has a y-intercept that's not 0, what does that mean? It's not a direct variation. Very good. What's the first step? If they give you an equation, Millie, what's the first step to take before we can determine if it is a direct variation or not? Yeah, it was. I'll just say, not necessarily y-intercept form, but solve for y. Get y by itself. All right, very good. Any questions? No, you will not have to graph them today. If you look at the problems today that are possibly or that are new are, let's see, 8, 9. You can kind of see it there. Tell whether this is a direct variation. Tell whether the equation 3y equals x represents a direct variation. 8 and 9. What else? 14, I think, is the same type of problem. Which equation represents a direct variation? 13. Something we just talked about. Explain why the graph of a direct variation will always go through the origin, 0, 0. So we talked about that as well, right? So I think those are the new problems for today. Caleb, I know you couldn't read all those questions when I put them into the camera, so you couldn't see the answers. I know you'll cheat. Caleb. You're on TV, Millie. You're going to be a big star someday. We'll see. We'll see. No, Caleb's not in here. I've never been happier in my life.